Today I'm looking at a problem to do with electromagnetic waves and waves in general, a little bit about the wave equation problem again. The wave equation comes up so often, it's one that you really should be very comfortable applying. So the first question, describe the difference between transverse waves and longitudinal waves. So it tells you radio waves are transverse, it tells you sound waves are longitudinal. This is such a common question that you really should be very confident at answering this question. And the key bit really comes down to what this transverse means, or actually what trans means. Trans means to go across, as in transatlantic cruise, or the Trans-Pennine Railway is going across the Pennines, so it's Trans-Pennine. So this bit of that word means to go across. So in this word, we're looking at the parts that vibrate, the parts that oscillate, are going across the wave. Or to be more precise, the vibrations and oscillations are at 90 degrees to the direction that the energy moves. Because remember, one of the things we can say about waves is that they're moving energy from one place to another. Okay, so again, I would be tempted with this, even though there's not a place to do a diagram, I would be tempted to do a little diagram just to show the examiner I understand exactly what's going on. So transverse, okay, the vibrations, and you really want to use the words either vibrations or oscillations. The vibrations are at 90 degrees, or you could say are perpendicular to the direction of energy movement. Direction of energy movement, or you could say actually the direction that the wave travels, and they would accept that. So that's transverse. The vibrations are at 90 degrees to the direction of the energy movement or the wave moves, whereas your longitudinal, here, the vibration is, and you can't say it's in the same direction, because if the energy on this sheet is if the energy is going from left to right, the vibrations are going to be from left to right, but they're also going to be from right to left, because these bits here are vibrating back and forth in that direction. So you should say is parallel. And then to the direction of energy movement. I've kind of run out of space there, but I'm writing a bit big. But you get the idea. The 2 marks, one in transverse, and I've seen people write transverse like this, to give them the big clue that it's that sort of a wave. It's a vibrations at 90 degrees, transverse. The vibrations or the oscillations are at 90 degrees to the direction that energy moves. Okay. Then we've got a simple little wave equation problem. So you're giving us the frequency and you're giving us the wave speed. Nothing awkward about the units here. The only problem are in standard form. You've just got to be used to using standard form. You've just got to be confident you can use that times 10 to the x, or on some calculators it's written as exp. But either way, it's going to put you into the standard form. You're going to rearrange the equation that the velocity is frequency times the wavelength. Use that funny little symbol lambda, Greek letter lambda for wavelength. And we're asking for the wavelength, so we want lambda to be equal to the velocity divided by the frequency. And so our velocity, it's an electromagnetic wave, so 3.0 times 10 to the 8 divided by its frequency, which is 4.8 times 10 to the 9 hertz. You pop that into your calculator and you will get an answer of 0.0625, but it's asking it for 2 significant figures, so we're going to have to round it up. I mean, the clues in the question again, this is to 2 significant figures and this is to 2 significant figures. So really, if we're doing it properly, we should put the answer to 2 significant figures anyway. So I'm going to put 0.06, and then should I go up down to 2 or up to 3? I'm going to go up to 3 because 5's halfway. So that's the second part, and then the last part describe how radio waves reaching car aerial produce signals in the electrical circuit of the car radio. So part of this, you can answer this question if you understand how radio waves are produced. If you've got some sort of electrical circuit, and part of your electrical circuit has got an aerial in it, okay, then what you can do is part of your electrical circuit will cause electrons, and some electrons in my aerial, it's going to cause the electrons to vibrate. They're going to oscillate back and forth. And when they do that, that is going to produce a radio wave. And again, nothing wrong with drawing diagrams on in your line paper. So if I was answering this question, I'm going to say, in my aerial, my radio waves are going to pass through the aerial, and that's going to cause the electrons in the aerial to vibrate at the same frequency as my radio wave. And so as long as I've got my aerial attached to some circuit that will detect that and amplify it and send it to my speaker, then that will mean that I can pick up whatever the radio signal is on my car radio. But the key idea is that you've got this electromagnetic radio wave. As it passes through the aerial, it will cause those electrons in the aerial to oscillate back and forth. It's kind of in sympathy with the radio wave, the same frequency as the radio wave. And so as long as your circuit attached to that aerial will pick up that signal, and you can amplify it, boost it, and then send it to the speaker, then you can hear the signal that's been sent along from the radio. Okay, that's that one for today.